Hello. Okay, just waiting for some more people to join. Okay, well, let's start in hopes people will join. This session is recorded, so and it's going to put that on YouTube. So today I'm going to talk about equations and inequalities. And just to begin with, I'd like to do some well, quite an interesting, as I found them interesting, equations. In most cases, you need to do a substitution. So let's have a look at problem number 1. We have a rational equation, so a rational algebraic rational fractions with x to the power 4. So any suggestion what we can do here? What would be the first step? Let x to the power 4 be y. Um, that's a good idea. Yeah, and you certainly get an easier equation. As a matter of fact, you can make it even simpler. You can say, why don't I make, not y, I don't really like, I like t more. So 2x to the power 4 minus 7. I can substitute that in. So let this. And then I can express t from here. I can express x to the power 4 equals t plus 7 over 2. And I sub that in. So t plus 7 over 2 minus 50 over t equals 14. And if I I find the common denominator, of course, and multiply. So basically, I multiply by 2t. Keeping in mind that t is not equal 0, so I'm not multiplying by 0. T is not 0, and we have to keep that in mind. So do you not see my screen? Is that a problem for everyone? Well, no, obviously, yes, obviously you can see that. Yeah, so try switching off and back on. You should be able to see it. Of course, you need to keep in mind the domain of the problem. 2x to the power 4 minus 7 must not equal to 0. That means x to the power 4 must not equal to 7 over 2. So x is not equal to plus or minus 4th root of 7 over 2. So if one of our answers is plus or minus 4th root 7 over 2, then we have to exclude that. I don't think we would need to do that, but anyways. So I multiply everything by 2t, so that becomes t squared plus 7t minus 100 equals 28t. T squared minus 21t minus 100 equals 0. 121. 25 and 4. So t minus 25, t plus 4 equals 0. So t1 is 25 and t2 is negative 4. And now I reverse substitute. So I got 2x to the power 4 minus 7 equals 25. And 2x to the power 4 minus 7 equals negative 4. So I solve this. 2x to the power 4 equals 32. X to the power 4 is 16. X is plus or minus 2. In here I have x to the power 4 equals 3 over 2. X is plus or minus 4th root 3 over 2. And okay, and those are the solutions. So there are 4 answers, so x1, 2, and x3, 4. Nice. Okay. Next one. Well, x to the power 2 plus x. Oh, Edward, would you, if you use, you can use this link to look at the question in real time. So if you'd like to, if you can't see my screen, you can use the link, the Miro board. Now, the next one is looks quite complicated. So it's x squared plus x plus 1 over x plus 1 over x squared equals 4. Now, I'm trying to come up with a reason why you would do that. But the standard approach in a situation like this, when you see pairs of opposite powers, so squared and minus 2, 1 and minus 1, the standard approach would be to let t equals x plus 1 over x. And you'll see why. Because if you do t squared, that becomes x squared plus 2x over x plus 1 over x squared. Ooh, interesting. So that is x squared plus 1 over x squared plus 2. And that means that x squared plus 1 over x squared can be replaced with t squared minus 2. And now we have a substitution. So we have t squared minus 2 plus t equals 4, and that's t squared plus t minus 6 equals 0, t minus 2, t minus 3 equals 0, so t is 2, or t is, okay, that is plus 3, so negative 3. And now we solve the equation. So x plus 1 over x is 2, or x plus 1 over x is negative 3. Of course, x is not 0, so we can multiply by x. So you get x squared plus 1 equals 2x. X squared minus 2x plus 1 equals 0. So x equals 1. That's the first solution. Now for this one, x squared plus 1 equals negative 3x. X squared plus 3x plus 1 equals 0. Apologies. Okay, so here I would probably complete the square. X plus 3 over 2 squared minus 9 over 4 plus 1. So that's plus 4 minus 5 over 4. So equals 5 over 4. X is equal to negative 3 over 2 plus or minus root 5 over 2. And these are the solutions. There are 3 of them. Okay. So you just need just a second. Apologies. I'm getting my session is getting hijacked. Okay, I'm back. And so the next problem is 2 fractions and 2 squares. Well, there are different ways you can approach this. You can just realize that if a squared equals b squared, well, there are 2 possibilities. It's either a equals b or a equals minus b. And you can take it from here. You could also say that let's take the square root of both sides. You can take the square root of a squared equals square root of b squared. Can somebody tell me what is square root of a squared? Well, there's a problem with that answer. Yes, it sometimes is a and sometimes is minus a, but it's not both. Like it's not optional. If you know what I mean. A function cannot return 2 different values, right? If a function returns 2 values, it's not a function. So, for example, this for some value of x, the function returns 2 different values of y. That means it's not a function. A function always gives you a single result. That means, okay, the square root of a squared is modulus a. and square root of b squared is modulus b. And here, well, we come to the same conclusion. If the modulus of a equals modulus of b, it means the same thing. It's either a equals b or a equals minus b. So we have two possibilities because their moduli are the same. I hope that makes sense. So so that basically becomes two equations. So x squared plus 6 over x squared minus 4 equal to 5x over 4 minus x squared, or x squared plus 6 x squared minus 4 equals minus 5x over 4 minus x squared. These are quite simple equations. We have to write down that x is not equal to plus or minus 2 because of the denominator. And now we can get rid of the denominator. So multiply everything by x squared minus 4. So we get x squared plus 6. And you notice that this denominator is the same, just with a minus. So that becomes minus 5x. X squared plus 5x plus 6 equals 0. X equals negative 2. X equals negative 3. So that's the second solution. Okay, here we have x squared, so plus 5x plus 6, no, sorry, minus 5x. Minus 5x plus 6 equals 0. And so I've multiplied everything, multiplied both sides by x squared minus 4. That takes these out. This becomes minus, 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 plus. Take it to the left, becomes minus. So x1 is 2. Sorry, x3 is 2. x4 is 3. However, we remember that x is not 2 or minus 2, because then the equation is impossible. So we have to exclude these. Exclude. So the answer is x equals minus 3 and x equals 3. That's it. Hope that makes sense. Let's move on. Simultaneous equations. So here, it might look scary. So first of all, we need to write down the domain. Domain meaning what are the limitations? What are the limitations on x and y? We see that x and y are under a square root. That means x plus y has to be greater or equal 0. That means x has to be greater or equal minus y. That's the first thing. And secondly, x minus y is greater or equal to 0, because you can't take the square root of a negative number. X is greater or equal y. Okay, so both of these have to be true. We'll just keep that in mind. Secondly, we need to find, we can do a substitution here. We can substitute. This is for u, so let u equals square root of x plus y over 2 and v x minus y over 3. And the equation becomes u plus v equals 14. Now we notice that we can take the 4 out. So 8 is 2 times 4. So it is u over 2 minus, you can take the 4 out here as well. So that's v over 3 equals 3. Oh, sorry, v over 2. v over 2. and then you get u plus v equals 14, u minus v equals 6, and then suddenly the system becomes much more simple. So the system becomes 2u, I'm adding the 2u equals 20, u equals 10, and v is u is 10, v is 4. V is 4. Now we go back to our original one. So x plus y over 2 square root is equal to 10, and square root of x minus y over 3 equals 4. So here we can square it. So x plus y is 200. Square here, x minus y equals 48. And now we can add the 2, so 2x equals 248. 2y equals 152. X equals 124. And y is 76. Nice. Oh, and that's the only solution. Now we check. Is 124 is greater than 76? Yes. And 124 is greater than 76, and 124 is greater than negative 76. So that's perfectly fine. So both answers are acceptable. That means that the answer, sorry, not both answers, the single answer is acceptable. 124, 76. Nice. Okay. This one. This one is harder. It doesn't look hard, but it is. What makes it hard is that it has both u, uv, uv, u squared, v squared, and it has square root of uv. So it has a whole bunch of things. Yeah, so that makes it not non-trivial. Okay. So what you can do is you can do a substitution. I'm going to substitute u as x squared, and I'm going to substitute v as y squared. So the inequality becomes x to the power 4 plus y to the power 4 equals x squared y squared plus 13. X squared plus y squared equals xy plus 3. Okay. Just a second. Okay. Now, You have to mention that UV has to be UV has to be greater or equal to 0, right? That means when you are taking the square root of x squared y squared, so like this thing, if you notice this, it used to be square root of x squared y squared. But how do we know that square root of x squared y squared is x y and not minus xy? But we know this because x y has to be UV has to be positive. So it has to be a positive number. UV is positive. Square root of UV is positive. No, sorry. Let's get back to that. No worries. Not that important at the moment. Okay, so now we can we need to realize that this part, that x squared, x to the power 4 plus y to the power 4 can be written as x squared plus y squared minus 2x squared y squared. Why is that? Well, because x squared plus y squared can be written as x to the power 4 plus y to the power 4 plus 2x squared y squared. Yes, if you just open the bracket. And then you express x to the power 4 plus y to the power 4 like this. So let's stick that in. And that becomes x squared plus y squared minus 2x squared y squared equals x squared y squared plus 13. On the bottom we have x squared plus y squared equals xy plus 3. And that means that here we can substitute this bit, we can substitute in here. So it becomes xy plus 3 squared equals 3x squared y squared plus 13. The bottom part I'm going to keep the same. X squared plus y squared equals xy plus 3. Does that make sense? Does that make sense to everyone? And now the top one we can attempt to solve because we only have one unknown. The unknown is xy. So xy is x squared y squared plus 6xy plus 9 equals 3x squared y squared plus 13. The second equation, it's just a copy. We can express 2x squared y squared minus 6xy plus 4 equals 0. We can divide the whole thing by 2, 3, and 2. Okay, and that brings us that xy is either 1 or xy is 2. Right? It's a quadratic equation. It's a quadratic equation in terms of xy. Do you see that, or would you like me to explain? Okay, and then at the same time, we just copy the last equation. So x squared plus y squared is xy plus 3. Okay, now we do the same trick with the x squared, with the last equation. We do the same trick. We say that x squared plus y squared, let's write it here. Similarly, x squared plus y squared can be written as x plus y squared minus 2xy. So I'm going to write that down here. So we have xy equals 1 or xy equals 2 and x plus y squared minus 2xy equals xy plus 3. In other words, xy equals 1 or xy equals 2 and x plus y squared equals 3xy plus 3. Nice. So we have xy equals 1 and x plus y squared equals, well, we substitute 1, so that's 6 plus 3 plus 3, 6. Or we have xy equals 2, and that is 6 plus 3, 9. So x plus y squared equals 9. So we have xy equals 1, x plus y equals root 6, or xy equals 1, x plus y equals minus root 6, or we have xy equals 2 and x plus y is 3, or we have xy is 2 and x plus y is negative 3. All right. So finally, we just need to solve. We need to solve the last one. So the last one is easy. 1 plus 2. So that's x equals 1, y equals 2. Or it's the other way around. Or x equals 2, y equals 1. So here, minus 1 and minus 2, x equals minus 1, y equals minus 2, x equals minus 2 and minus 1. Oh, wow. It's getting interesting. So here, they multiply to 1, but they add to root 6. That looks like. All right, so this is the solution of the last two. So these are the 4 solutions for the last 2. Now let's consider this separately. So xy equals 1, x plus y equals 6. Well, let's make x root 6. Sorry, make y the subject. Y equals 1 over x. Substitute that in. X plus 1 over x equals root 6. X squared plus 1 plus equals root 6x. X squared minus root 6x plus 1 equals 0. Well, I'll have to use my calculator machine for that because So that's 1 minus root 6 and 1. Okay, so x is root 6 plus or minus root 2 over 2. That's 1 and 2. And y, correspondingly, if x is that, then of course x cannot be negative because x is well, it doesn't matter whether x is positive or negative because u is x squared. All right. Well, anyways, x is 6 plus or minus root 6 root 2. Now, if x is that, then y is square root of 6 minus plus root 2 over 2. 1, 2. And finally, we reverse substitute. So from here we get x is equal to root 6 plus root 2 over 2, and y is root 6 minus root 2 over 2. We get x equals root 6 minus root 2 over 2, and y is root 6 plus root 2 over 2. And then we substitute. We're not interested in the negative ones because u is x squared, so it doesn't matter. So these don't matter. So we have 4 solutions, and then we do the backward substitution. Sorry for making a mess here. And we get u is equal to square root of 6 plus square root of 2 over 2, and v is square root of 6 minus square root 2 over 2, which is, as a matter of fact, 2 minus square root 3, and this is 2 plus square root 3. Or u is square root, well, it's the other way around basically. U is that, v is that with a plus, and that is 2 minus. No, that's not possible. So that's plus. That's silly. This is obviously larger, so that's plus, and that is 2 minus root 3, and this is plus 2 root 3. Okay, then we have u equals 1, and v equals square root 2. Oh, sorry, v equals 4. Squared, not square root. I finally got it. Okay, so and then u is 4 and v is 1. Okay, that makes more sense. Sorry. These are the solutions. So the answer for this question is 1, 4, 4, 1, 2 minus root 3 and 2 plus root 3 and 2 plus root 3 and 2 minus root 3. Okay, so you can see how suddenly the difficulty of simultaneous equations can just skyrocket, can just goes through the roof when just a few things are not are not non-standard. We have some of these. We have a similar question in the assignment. I don't know if it's solved similarly, but it's yes. Now the next one is also slightly monstrous. So please brace yourselves effectively. Okay, so just get my notes. Okay. Right, so we are going to write the first equation as y plus z equals 2 minus x. And now we will square that. So first equation in a square, it becomes y plus z squared equals 2 minus x squared. And that becomes y squared plus 2yz plus z squared equals 4 minus 4x plus x squared. And now from the second equation, we see that y squared plus z squared equals 6 minus x squared. We can sub that into this one. So that becomes 6 minus x squared plus 2yz equals 4 minus 4x plus x squared. So simplifying this, we get 2yz equals 2x squared minus 4x minus 2, which simplifies to yz equals x squared minus 2x minus 1. Okay. Now take the same equation, number 1, and then we're going to cube it. Cube the this equation. So we're going to have y plus z cubed equals 2 minus x cubed. That becomes y cubed plus 3y squared z plus 3yz squared plus z cubed, and 2 minus x cubed, that is 8 minus 12x plus 3 times 2, that's 6 x squared minus x cubed. 8 minus 12 plus 6 minus, yes, okay. Now y cubed plus z cubed minus 3yz, open bracket, y, sorry, plus z equals 8 minus 12x plus 6x squared minus x cubed. Now from the third equation, we're doing a very similar thing. From the third equation, we get y cubed plus z cubed equals 8 minus x cubed. And we sub that in. So that becomes 8 minus x cubed plus 3 yz, y plus z equals 8 minus 12x plus 6x squared minus x cubed. And now the important stuff. This we take from here. This is expressed in terms of x. Now y plus z, we already know y plus z is this bit. We take it from here. Oh yes, and now we have equation in x. And the most beautiful thing is that x cubed cancels. So now all we need to do is just relax and enjoy. So it's 3 multiplied by x squared minus 2x minus 1 multiplied by y plus z, that's 2 minus x, equals minus 12x plus 6x squared. Open the brackets, 3, 2x squared minus x cubed minus 4x plus 2x squared minus 2 plus x equals minus 12x plus 6x squared. I just noticed you can simplify by 3, so that's 6 and that's 3. That makes life easier. And then we have 2x squared minus x cubed minus 4x plus 2x squared minus 2 plus x equals minus 6x plus 3x squared. X cubed minus x squared minus 6 plus 3, so minus 3x, then plus 2 equals 0. Now we need to solve this cubic equation. X cubed minus 2x squared minus x plus 2. I think I made a mistake. Let me check. Plus x. Y plus z is 2 minus x. Yz is x squared minus 2x minus 1. 2x squared minus x cubed plus 2x squared. Oh yeah, I obviously messed up here. So that's 2x squared minus x cubed minus 4x plus 2x squared minus 2 plus x minus 6x squared plus 3 y plus z 8 minus 12 plus 6x squared minus x cubed. Y cubed plus z cubed is minus 8 minus x cubed. Making a mistake somewhere. Apologies. One minus two minus one, two. Not sure. I'm getting a different result. Let me check. 1 minus 1 minus 3, 2. Eight cancels, minus x cubed cancels. You get 3yz. Yz is x cubed, x squared minus 2x minus 1. Y plus z is two minus x. I'm not sure what exactly went wrong. The correct one, the correct equation is x cubed minus 2x squared minus x plus 2. And then you solve this equation and you get x equals 1, x2 equals minus 1, and x3 equals 2. And then you solve, and then you find x or find y. How do you find y? Well, you use the equation yz. So here yz equals x squared minus 2x minus 1. So that is yz is x squared minus 2x. So 1 minus 2 minus 1, so that's minus 2. And it's minus 1. So it's 1 plus 2, so 3 minus 1 is 2. Yz is 2. And here yz, 4 minus 4, that's 0. Minus 1, minus 1. Okay. Now, yz, because from here, because you know that yz is minus 2. So, and from the first equation, you get that x plus y plus z is 2, and that means that y plus z is y plus z is 2 minus x, so that's 1. Y plus z from the first equation. Y plus z is 2 minus x. So y plus z is 3. Y plus z is 2 minus x, so that's 0. Okay. And then we solve these. So from here, we have x equals 1. Y is equal to 1 and minus 2. So minus 2 and z equals 1. Or we have x equals 1, y equals 1, and z is minus 2. Then we get x equals negative 1, y equals, so 2 and 3. They multiply to 2, add to 3. That's 2 and 1. 2 and z equals 1. Or it's the other way around. X equals minus 1, y equals 1, and z equals 2. So I'm just solving. There are two possibilities here. Yz is 2, y plus z is 3. So the last one, we have 2, x equals 2, y equals, so minus 1, they multiply to minus 1 and they add to 0. So that's minus 1 and 1. 1 and z equals minus 1. And finally, x equals 2, y equals minus 1, and z equals 1. Now, a very similar question is in the assignment, so I hope you paid attention. Now, I don't know what happened here. I've double checked it twice, and I still, of course, I know what happened. I am very bad at dividing by 3. 12 divided by 3 is 4, and 6 divided by 3 is 2. And that is why this would be minus 4, and this would be 2. And the equation becomes minus 4. So it's minus 1, minus x, 2x squared. So minus 2x squared plus 2. Yes. Okay, I found it. Apologies for that. Okay, so that is it. Well, I've spent an hour on equations and we haven't touched inequalities, so I'm going to rush to inequalities. Inequalities are slightly easier in a way. So first of all, we need to understand the method of intervals. If you look at this function and you try to plot it, you will see that actually it's quite an easy function to draw. Just like you draw the cube, if you were to try to sketch this graph, this is 0, 1, 2, 3, 4. This function, f of x, would squiggle like this. Go down, up, down, up, down, up. F of x. Okay, I hope that makes sense. This is 0, 1, 2, 3, 4. Any questions? Any questions? So when I ask you to solve this inequality, it's just asking the question, when is this function positive? This is equivalent to asking when is f of x positive? And it's positive when it's above the x-axis. It's positive here when x is more than 4. It's positive between 2 and 3. It's positive between 0 and 1. So it's positive here, positive here, positive here, negative here, negative here, negative here. So this question 5 of physics assignment 2. Let me finish this this one, and I will go through the physics assignment 2. Oh, that was a while ago. Okay. Right. So yeah, let me finish this question. When is f of x positive? Well, it's positive when x is from 0 to 1, or from 2 to 3, or from 4 to plus infinity. Okay? And you can see that the function is positive here, here, and here. We call them intervals. There are 3 intervals where the function is positive. Now, if you look at this function, it's actually doesn't make much difference because it has the same blocks. It has the same building blocks. So these brackets are the same. And if you can imagine that if this function is positive, that also means that this function is positive. Like if this is a positive fraction, moving one of the multiples from top to bottom does not change the sign. Right? You can imagine numbers like 3 multiplied by -2 multiplied by -1 divided by 2 and -4. Moving one of the numbers from top to the bottom side does not change the sign of the overall sign of the fraction. So this function, even though it doesn't look like the previous function, it has the same intervals. So we can still draw this function with the same intervals, 0. We call these critical points, by the way. They're different to the critical points in differentiation. 0, 1, 2, 3, 4. We check a large number, so x 100, for example. If you place 100 into this x is positive, x minus 1 is positive, 100 minus 4 is positive, positive, positive. So the function is positive here. And then between 3 and 4, all of them are positive except x minus 4. So if you take a value between 3 and 4, for example, 3.5, this would be negative. So the whole fraction is negative. Between 2 and 3, this would be negative. So positive, positive, negative, positive, negative make positive. Between 1 and 2, that means we're between 1 and 2. So this thing is negative now. So positive, positive, negative, 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 which makes the whole thing negative. Then positive. Negative, positive, negative. So it's the same. It's the function also squiggles like this. It doesn't look exactly like this because it has at 2 and 3 it's discontinuous. So, but the signs are like that. And the question is, where is this function negative? This function is negative here, here, and here. So the answer that x belongs to minus infinity to 0, from 1 to 2, and from 3 to 4. Or from 3 to 4, sorry. It's not and, it's or. Right. Finally, oh, what have I done? This one is the same function, except now it's greater or equal. So we find the critical points, we identify the critical points. The critical points are 1, 0, 1, 2, 3, and 4. 0, 1, 2, 3, 4. Now, x cannot equal to 0. X cannot equal to 0, x cannot equal to 2, x cannot equal to 4. However, x can equal to 1, so we draw a solid dot because it's greater, it's greater or equal. And x can equal to 3, so we draw a solid dot at 3. And now we do the same thing. We start with a plus, minus, plus, minus, plus, minus. The function squiggles and it goes down. Now we draw a round bracket here, a round and then a square bracket. I'll show you later why. And it goes round, squared. Squared means included. So an right angle means included. And a solid dot means included. Greater or equal 0, so that means the positive intervals. It's greater or equal 0, so we need the positive intervals. And that means x belongs to, from 0 to 1, including, means including 1. Or from 2 to 3, including. Or from 4, not including, to plus infinity, not including. We never include infinity because infinity is not a real number. And that is the answer. Okay. I have been rushing a little bit with this question. I have done several webinars on the method of intervals. So please roll back to my previous webinars, to last year's webinars, and watch webinars on the method of intervals if you're still confused. Now, quickly change of scenery to physics, question 5, physics assignment 2. So, okay. Physics assignment 2, question 5. Okay. I am doing a webinar next week on this topic. So if you join next week at the same time, I will go through this assignment. Okay, so please join next week. Is that okay? Because I was particularly asked to give an extra webinar on this topic. So please join next week. Is that okay, Edward? Now, well, you won't be able to watch the recording, so I'll make sure to go through that question. Okay. I'll make a note for it. Or I'll make a note for myself. But effectively, it's a car going down a spiral ramp, right? So it's going down a spiral ramp, and you just need to look at the car from the top, and the centripetal acceleration is v squared over r. That's pretty much it. And the force equals mass of the car v squared over r. So yeah. Now this question, you can solve it using the method of intervals. So we just put everything to one side and we factorize the denominators. So it's 1 over x plus 1 minus 2. This is not factorizable, so we can keep it as it is, plus 1 minus 1 minus 2x divided by x cubed plus 1, so x plus 1. You can factorize this, and this becomes x squared minus x plus 1. You can verify that this is true by yourself if you're not familiar with the sum of two cubes formula, sum of cubes. And then, so we multiply this by x squared minus x plus 1. We multiply this by x plus 1. We don't multiply this by anything, so x squared minus x plus 1 minus 2x minus 2 minus 1 plus 2x, and this cancels. I was hoping that would cancel as well, but it doesn't. X plus 1, x squared minus x plus 1 is equals 0. Oh, it's just a quadratic. Okay, nothing scary. X squared minus x minus 2 over x plus 1, x squared minus x plus 1 less than 0. Now we factorize the top. This becomes x plus 1. Ooh, interesting. X minus 2. And then x plus 1, x squared minus x plus 1. Now, you might be tempted to get rid of the x minus x plus 1. It's not a very good idea to do that, because what if x is minus 1 and then you're dividing by 0? You have to exclude x equals minus 1. So the critical points x equals minus 1 and x equals 2. This is always positive. X squared minus x plus 1, always positive, because if you complete the square, you will see that. And then we just need to draw the function, or sketch the function. Now we say, okay, so we have 2. Now 2 is a solid dot. Then we have minus 1. Minus 1 is a round dot. Now we check a value, a very positive value. So for example, 100. If we place 100, positive, positive. So that's positive, 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 positive. So positive, negative. Now at minus 1, the sign changes twice, because there are 2 x plus 1 brackets. So the sign doesn't change overall. So positive, negative, negative. We go square bracket, round bracket, round bracket. And then the question is, where is this thing negative? And it's negative here, and it's negative here. So we say x is from minus infinity to 1, and from 1 to 2, including. Right. The next question, this one. Now this question, you can't, well, it's not worth trying to doing it using the method of intervals, and it's not worth trying to do it analytically. So normally I would say, well, modulus of x is either x or minus x, depending on the value of x. So if x is positive, it's that, and if x is negative, it's that. But that will actually make it much more complicated. So what I would suggest doing here. So it's a fraction. The fraction is greater than 0, and that means that either the numerator is positive, so either you're dividing a positive number by a positive, or you're dividing a negative by a negative. But on the bottom you have a square root, so the square root is always positive. So this is positive. That means this is equivalent to saying, well, modulus of x plus 2 minus modulus of x is greater than 0. However, the square root has to exist. That means 4 minus x cubed has to be greater than 0. It can't be equal to 0, because then you're dividing by 0, so it has to be positive. Okay. Because this is always positive, it can't be negative. That only means that x plus 2 minus modulus x is 0. The bottom inequality is easy. It's x cubed less than 4. So x is less than cube root of 4. That's easy. What about this one? Modulus x plus 2 greater than modulus of x. The easiest way to do this is by sketching the two graphs. Modulus of x looks like this. This is modulus of x. And modulus of x plus 2 is the same graph, let's shift it to the left. Okay, so modulus x plus 2. So the question is, where is modulus x plus 2 greater than modulus x? And the answer is, it's from this point, which is where they are equal. So that's where x minus x equals x plus 2. So 2x equals negative 2, x equals negative 1. And that happens when x is greater than negative 1. And this is x is less than cube root of 4. And that's your solution. The answer is x from negative 1, not including, to cube root of 4, not including. Okay, next question. Here, you do need to use the definition of the modulus. And you would say, okay, so if x is greater or equal to 0, then modulus x is x. And then you have x squared minus 7x plus 10 over x squared minus 6x plus 9 less than 0. You factorize x minus 2, x minus 5, x minus 3 squared less than 0. And then you use the method of intervals. So the critical points are 2, 3, and 5. Positive, negative. There's no sign change at 3 because it's squared. X minus 3 squared is always positive, so it's going to be negative and positive. So positive, negative, negative, positive. And it's less than 0 for these values. So x, and we have to keep in mind that x is greater or equal to 0, and that is fitting. So 0, we have to keep that in mind. So x belongs to from 2 to 3 and from 3 to 5. Not including. And then if x is negative, then modulus x is negative x squared plus 7x plus 10 divided by x minus 3 squared less than 0. So x plus 2, x plus 5, x minus 3 squared less than 0. As critical points are minus 5, minus 2, and 3. We don't care about the 3 because we are less than 0. We are only interested in the values that are less than 0, so the function goes like bam, 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 bam. So positive, positive, negative, negative. We need negative values, so that's between minus 5 and minus 2. So x is from minus 5 to minus 2, and so the answer is x belongs to from minus 5 to minus 2, or from 2 to 3, or from 3 to 5. Cool. The next one is actually quite simple as well. So on the top you have a square root. So the square root is always positive. The square root never returns you negative values. So the square root is positive, and the bottom is x plus 3. So in order for the whole fraction to be positive, all you need is x plus 3 to be positive. The square root has to exist. And that means 17 minus 15x minus 2x squared has to be greater than 0. It can't be equal to 0 because then it's equal to 0 and it's not greater than 0. So it has to be greater than 0. All right, so x has to be greater than -3. And at the same time, this thing, so we can do this by completing the square. So -2, -15, 17, and that is 1 and oh really? So x -1 and 2x -17 with a minus and greater than 0. So we can do sort of a method of intervals here. So that is 1 and -17/2. Round, round, and that's negative, positive, negative because there's a minus. It makes the whole thing negative. So like this. It's greater than 0 between these values. So it's greater, -17/2, that's less than -3. So on this, at the same time, it has to be greater than -3. So the answer that x belongs from -3 to 1, not including. Nice. Finally, we got problem 8. Find the domain of the function. So what are the limitations? Well, the limitations are that to find the domain of a function, you need to find what are the limitations on x. You can't divide by 0. So x minus 5 has to be greater than 0. Oh, sorry, not equal to 0. That's the first limitation. The second limitation is that you can't take the square root of a negative number. And so that means 9 minus 4x minus 22 over x minus 5 squared must be greater or equal to 0. So here we can write 4x minus 22 over x minus 5 squared is less than or equal to 9, x minus 5 not equal to 0. And then this bit, well, if it's less than 9, if it's less than 9, this x is not equal to 5. And here 4x minus 22 over x minus 5 has to be less than 3, but greater than -3. And so we can solve these x not 5, 4x minus 22 over x minus 5 less than 3, 4x minus 22 over x minus 5 greater than -3. So x is not 5, 4x minus 22 minus 3x plus 15 over x minus 5 less than 0, 4x minus 22. I can't multiply by x minus 5 here because I don't know if x minus 5 is positive or negative. So yeah, so plus 3x minus 15, x minus 5 greater or equal to 0. So that is equivalent to x not 5, x minus 7 over x minus 5 less than 0, less than or equal to 0. 7x, 15 and 22, that's 37 minus 37, x minus 5 greater or equal to 0. And so for this one, that's fairly easy. That's 7 including, 5 not including, and it's less than 0, so it's like this. So x belongs to, well, you can just simply say x less than or equals 7, and less than 5, greater than 5. X is not 5. And here, this one's a bit tricky. We have 5 and 37 over 7. That's less than 7, certainly. Okay, so that is like that. It is greater than 0, so it's here or here. And that's 37 over 7. So that means x is less than 5, or x is greater or equal 37 over 7. And overall, that means x belongs to from 37 over 7 to 7 including, and that is the answer. I hope that makes sense. Apologies for rushing through the last few questions. Yeah, so the domain of this function, the domain is from minus 37 over 7 to 7, including. And we can actually check that for, so if you draw Desmos, oh, okay, y equals square root 9 minus open bracket fraction 4 minus 22, or x minus 22. And here we have x minus 5, x minus 5, the whole thing bracket squared. And you can see clearly that the function only exists between this value, which is here, to here. Okay, from 37 over 7, roughly, to, yeah. Okay, so I hope that was useful. If you are confused, please watch my other webinars. And tomorrow, next week, I will talk about circular motion, and this is a separate webinar. It's dedicated to assignment 2. All right, see you everyone, and yeah, enjoy your Easter holidays and your week. Welcome.